So in this part, I will be talking about the second supervised learning type, which is regression. And in the regression, instead of labels as you saw before where we had the apple and the banana, this type of label is different. This is basically a float. And it's not a label as a string. It's not, for example, 1, 2, 3, 4, 5. And it's not. It's a price, for example, or anything that has a value that can change from like up and down. So a value, just like you can see here in this example. But these numbers are not relevant to the images that they have in front. But we could count this as, for example, a price if we had this one as positive, but it is not positive. So the usual one of the examples on which we will use in our example, the next that comes later, is basically when we have height and we want to predict the weight of a person. So let's say if we had this equation and our y is the weight and our x is the height. So let's say my height is 182 centimeters. If we compute this, then I can come up with my weight. So using this equation, we can find the weight of any person, and it doesn't always work, but it works as an average. And with that, we can show this. So basically, in regression, we are drawing a line in the middle that looks like y, x. If you remember your old classes of math and math classes and algebra classes, this is how it looks. So let's get to the example. So here I will do a linear regression example. We have two classes, weight and height data set of 25,000 people. We want to regress a line like y equal ax plus b, so that we will be able to find the weight of a person given the height. We evaluate the model by splitting the data into 90% training and 10% testing. So as I said, in this example, I'll be talking about linear regression. The two classes, we have one class which is weight, and we have height as parameter. So we want to discover weight using the height of a person. We have a data set of 25,000 people. We want to predict this equation, which is y equal ax plus b. So basically, we want to regress a and b until we find these values, the middle values for these two numbers, so that we can find y using x. For any y, we can find x. For any x, we could find y. So to do this, we will evaluate the model, splitting the data into 90% for training. As I explained before at the first slides in machine learning, we need training data. So in this case, we will use 90% of the data as training, which is 22,500. So 22,500 data will be used for training, and then 2,500 will be used for testing. Why testing? Is because we want to know how our model is doing. Because imagine you build the model and you don't have testing data, then you don't know how good is your model. So for that, we will use mean square error, which is a famous metric to test the error and error rate. And then in this, you can check it out on Wikipedia or something if you don't know it already. So let's get started. So here I will open. You can find the example on the folder that I have explained at the beginning of the slide how to download it. So the file name is LR example, which stands for linear regression example. So here I have imported a few libraries that we will use during our coding. So here we will download the sklearn library, and then we import this linear model, which is the model that we will be using for our example for linear regression. NumPy, which is a library for useful mathematics, and then matplotlib, a famous library for plotting. And then we have sklearn metrics, which has mean square error and R2 score. So both of these are scoring matrices, the metrics that we will use later to tell how our model is doing. So first we will create two empty lists. Here we will open the file, which is dataset. You can find that file in your example folder. So as you can see here, The data set is here. It is a text file. You can just open it with text using a text editor. It is not labeled as txt, so you can't see it, but if you open it, as you can see here, we have three variables. One is the index. It's the index of our data set, and then we have the weight here, and then we have the height here. So this is the number of people. So if you go to the last line here, it's supposed to be 25,000 data. So yes, let's show. So in that file, we already discussed how to open a file and how to loop over the lines of that file. So here we are going to, for each line in that file, we give x a line. So we split the line using a tab. So the data is separated by tabs. So for example, the index and the height and the weight is separated by tabs. So if we split them using this method, then we will have three variables with different, so we will have a list, and inside the list we have three different values. So in this case, we are appending, so that we use this variable that we created in the beginning, we're appending the float of x1, which is, x is here, so x1 represents the height, or the weight. So we're appending that to our x data list. We're changing this to a float because it used to be a string before, so it is now really a value and we can't use it as long as it's a string. So what we do with that, we change it to a, so as I said, we change it to a float so that we can read it, and then we can use it for multiplications and stuff. And the same thing goes for the height or weight for the second value, and we will append it to the y data. So basically we split the x data separately, which are the data that we have, and the y data is the list of the data that we want to predict. So, and then what we do is basically, here is a way to actually split the data into testing and training, just like I said. So here we leave it empty, but you can write a 0, it still works, the same thing. The reason I didn't do that is because this is a common way to do this. And it is self-explanatory if you know Python. But you could write them up like this. So basically what we are saying here, we're saying that xtrain receives the x data from 0 to 22,500, and ytrain, which is also the same thing, receives from y data from 0 to 25. So we already filled all x data with all the data we have, and the y data with all the data we have, and here we're splitting that data to training and testing. So nparray changes is another function that changes a list to an array. There is a difference because array has more functions and have more. We can do a lot of things with an array which we can't with a list. So for example, this is one of them, which is reshaping. So we reshape. Let me show you before we do that. Let me show you how it looked before and how it looks now. So print x data. There we go. This is the one we have. Print x data from here. Okay. Now if we can also print the length of this list. Length, so that you see that it actually is 22,500. Okay, and then thirdly we will print the reshaped after we turn it into, oh no, let's print it as an NP array as well so that you see the difference. And then finally we'll print this one with a reshaped form. Okay, so now let's hide this because we don't want this to happen. We just want to see the data. There we go. We will just uncomment these one line by one once we are running this. I will explain all these lines, so don't worry for now. Here we go. We commented all these lines, so these are not going to run. This is the only part is going to run, and this is the one where we have learned until now. So let's run this. As you can see, so this is a list. This is where we run. So we run it here, and we have a very long list of size 20 to 500, and at the end of the list, it is supposed to show us the size of that list. Here we go. So as you can see here, this is the end of the list, and here we printed the length of that list. So it is 20 to 500, and then we changed it into an array, and this is how an array looks like. Because an array is smarter, it doesn't want to print all that in one go. It knows that it's too big to be printed, so it's just going to print this, which and 3 points in the middle that shows that actually the list is much longer than that. And then if we reshape it to -1, 1, this is how it looks. So basically, reshaping is when you change this how the array looks like, and change it to a way. We do this is because our function, the linear regression function, needs that as needs our error input as looks like this in order to work. Otherwise, it's not going to work.